So this is just going to be a quick little video to help you out with the Discrete Math Activity 2, Finding Hamiltonian Circuits and Paths. It's got 5 questions to it. Question 1, we're going to find 3 different Hamiltonian circuits that start with D. And then we have this first graph here. So I do have this first graph up here on this board. So if it's a Hamiltonian circuit, it has to start and end at the same vertex. So this problem is telling you that they want 3 different circuits that start and then they also have to finish at D. Start at D and we'll finish at D. Now we also are going to find paths here that they tell you where to start and where to end, and that's the nature of a path. So again, a circuit starts and ends at the same vertex, and a path starts and ends at different vertex. So I'm just going to do an example here for the one of the Hamiltonian circuits that start with D, and hopefully this will help you finish the rest of those. So here we have D. D is right here. It's that vertex here, so we'll just label that as D here. Now I'm going to have to hit every vertex along the way, and then I have to finish at that D as well. So one thing I always watch out for when I'm grading is, can I actually get to D from the next to the last vertex? So from G doesn't go to D, so we can't do that combination here. So I'm just going to start here. I'm going to go up to B. So here we are at B. Let's go over to C, like so. We'll drop down to G. Go to F here. Pick up E. A is the only other vertex that we haven't hit. And from A, I can finish at D. So that's what one of the complete Hamiltonian circuits can look like. So I went up to B. If you start at D and drop down to F, you will have a different circuit. So all I need to see is 2 different, one switch of vertex to be a different circuit. So if you look at question 2 has a different circuit to play around with, but it's the same question. There's nothing different here. You're going to find 3 different Hamiltonian circuits. They're not telling you where to start, so pick a vertex, but you got to be able to finish at that vertex as well. And then you're finding 2 different paths. They are telling where to start and where to finish. Now looking at question number 3, list as many Hamiltonian circuits in this graph as you can find, and they give you a different graph to play around with. And you're going to be using this one in number 4 as well. So list as many as you can find. I'm looking for 6 for full credit here. Circuits, again, have to start and end at the same vertex. Nobody's telling you where to start and end, so you can just keep picking a different vertex here. So if I start with A, I'll go to B. I have no choice really but to go to D. From D, well, I could go to C. C takes me to E. And then E takes me to A. So again, I'm starting and finishing, and that is a circuit. So 6 for full credit. Questions 4 and 5 all have the same theme. You're using different, what we call algorithms, to be able to find the easiest, cheapest way of getting through these circuits. You're a transport company and you want to be able to save gas, so you are finding the cheapest way to be able to do that. So we have nearest neighbor. Nearest neighbor, you start at a particular vertex. As you see different ways of going, you take the cheapest way there to the next vertex. From there, you take the next, again, least expensive way of moving yourself around. You're not allowed to finish a circuit until you complete every other vertex and take yourself back to your starting place there. The other way of doing it is called cheapest link. cheapest link, you look at all the alternatives across the whole system, and you start putting together a circuit starting with the very, very least expensive and then the next least until you put that circuit together that way. Now, this exercise also talks about a least costly way. I think what they're really talking about here is what we call the brute force way, which is to actually put together every circuit and see what you get. These Goldfield problems they're the sum of all of the lengths as you put the circuit together, and when the answer is correct, they turn to white. So again, this is the same circuit as we had from question number 3. We're going to do a nearest neighbor on it, and it says nearest neighbor starting at A. So here's A up here. So I have a choice of a 5, 7, 9, or a 3. Obviously the 3 is the easiest, cheapest way of going. So I'm going to go A to B, and I'm going to note that that's a 3. Now I only have one thing I can do here from B to D, and that's an 8. Here, though, I could take a 6 or a 4. That's the next. So D to C, and that's a 4. From C, I have to make my way back to A. So no, I would never do that anyway. So C to E is a 7. And that E takes me back to A. And that's a 5. If I add all those up, $27. It all adds up to 27. So 27 goes into that gold field, and that will clear it. So one suggestion when you're playing around with these is you do algorithm, try that same answer, because often they do give you that same answer, but not always. See what you can do with the cheapest link on the other one.